we can see the particles by our naked eyes. We do not need any instruments to view the particles of a suspension. With our human eye, with our naked eye, we can see the particles of suspension. And the particle size is greater than 1000 nanometer. That's why we are able to see with our naked eye. The particle size is greater than 1000 nanometer. It is greater than 1000 nanometer. That is the reason why we can see the particles with our naked eyes. Now, what is a physical change? Now I am explaining a physical change. If you are asking a question that explain suspension, then you have to write a suspension is a heterogeneous mixture in which colloidal particle does not dissolve but remains suspended throughout. The particles of suspension can be seen with our naked eye and the particle size is greater than 1000 nanometer. These are the important characteristics of suspension. Now, you are getting a question, a 1-mark question, that what is a physical change, or differentiate between a physical change and a chemical change. A physical change is a change in which size, shape or appearance may alter. That means the size, shape or appearance of an object may change, but its chemical composition remains the same. Chemically, there is no change happening to that object. Only physically the changes happen. That is, the size may vary, the shape may vary, and the appearance may vary, but chemically the substance remains the same. The chemical composition of the substance remains the same. Then that type of change is called a physical change. Also in physical change, no new substances are formed. The previous substance remains as what it is. I am considering a substance, let it be A. Let it be A. I am considering a substance, let it be A. I am changing this as like this. This is also A. This is also A. This is also A. The way I write A is changed in different ways. But the alphabet remains the same. It is the same A. I am just slanting or reversing. But the alphabet remains as A. Like the similar way, if an object changes its size, shape or appearance, but its chemical composition remains the same. Chemically, no changes happen to that object. That is a physical change. In physical change, no new substance is formed. Previous substance remains the same as what it is. Only appearance or size or shape may change. That is a physical change. Now, any change that involves the formation of new substance and leads to the formation of a chemical identity, transformation of a chemical identity, is called a chemical change. That means in chemical change, a new substance is formed. Any change that involves the formation of new substance. That means a new substance is formed here and leads to the transformation of chemical identity. That means the chemical identity of previous substance changes to a new one. If we are burning a paper, the paper burnt and then it becomes ash. Then the nature completely changes. Ash is carbon. The property of carbon is very different from that of paper. That means chemically the paper changes to that ash or that carbon. Like the transformation of chemical identity happens, it is a chemical change. Any change that involves the formation of new substance and a new substance is formed. When a new substance is formed, the chemical identity surely will change. That changes are called chemical changes. And chemical changes are usually accompanied with heat exchange. Chemical change always happens with a heat exchange. Heat may exchange from one substance to another, and a chemical change can happen. They are permanent and irreversible. Chemical changes are permanent. If we burn a paper to ash, then this ash cannot be reversible to paper or cannot be converted back to that paper. That's why it is called permanent and irreversible. That's the difference between physical change and chemical change. Now, I will give you some more definitions which may be useful for you for your board examination. If you are asked to write what a saturated solution, unsaturated solution, or a supersaturated solution, just differentiating, a saturated solution is the solution in which maximum amount of solute is dissolved in a solvent. Saturated solution is maximum amount of solute dissolved in a solvent. Then the solution is called saturated. Then unsaturated solution. Unsaturated solution is that we can add more solute to the solvent. If we can add more and more solute, then the solution is unsaturated. We add solute again and again, then it becomes saturated. Then one more thing, supersaturated solution. The supersaturated solution is a solution in which more solute is added than its saturation level, than a saturated solution. If we are adding more solute to a saturated solution, then it becomes supersaturated. That's the difference between saturated, unsaturated, and supersaturated solution. Now I think it's clear to you what a suspension is and what a physical change is and what a chemical change is. Then we explain what saturated, supersaturated, unsaturated solutions. All the theoretical portions in this chapter are completed. Now we are going through a simple problem. The problem is that a solution contains 60 gram of common salt in 240 gram of water. That means here the solute is common salt and the mass of solute is 60 gram and the solvent is water. Mass of solvent is 240 gram. Calculate the concentration in terms of mass by mass percentage of solution. We have to calculate the concentration by mass percentage. We know the equation already. We go through the equation as mass by mass percentage. Mass by mass percentage is equal to mass of solute by mass of solution into 100. Here the solute is common salt. Therefore, mass of solute equal to 60 gram. And we know that water is the solvent. Therefore, mass of solvent is equal to 240 gram. But here in this equation, we need mass of solution. Mass of solute plus mass of solvent gives mass of solution. Mass of solute plus mass of solvent gives mass of solution. Therefore, mass of solution is equal to mass of solute 60 gram plus mass of solvent 240 gram is equal to 240 plus 60 is 300 gram. Now, mass by mass percentage can be expressed as mass by mass percentage equal to mass of solute, that is 60, by mass of solution, that is 300, into 100. These two zeros can be cancelled that is 60 into 1, 60 divided by 3. 60 divided by 3 is 20. It's 20%. Mass by mass percentage of the solution is 20%. Is it clear to you? Given the mass of solute as 60 gram, mass of solvent as 240 gram. We need mass of solution. Mass of solute plus mass of solvent always gives mass of solution. Then we can find mass by mass percentage as mass of solute by mass of solution into 100. Okay, that's all about our chapter, nature of matter. Now just recollect what we have studied in this chapter. First of all, we have studied or explained the elements, then compounds, then mixtures, solutions, colloids and suspension. In colloids, Brownian movement and Tyndall effect is the important one. And in solution, to express the concentration of a solution, and dilute solution, concentrated solution, then saturated, supersaturated and unsaturated solution. That's all we are discussed in this chapter. Remember these all terms, these are very important and you are getting short questions from this topic. So study well and use this for your future reference too. And I am Nitishas and thank you for joining me in this section. Let us meet with another section in another day.